Hello, in this help video I'm going to show you how to do a one-way chi-squared test using R. We're going to be using the example data from chapter 6. You will either can get this data file from the online resource centre, or you can construct it yourself as shown in the previous video. What you need to do is you need to open R. The first thing you need to do is to open R, and then once you've opened R, open a new script file. And for ease I usually vertically tile them. Now what we need to do is put the code that we're going to use to get R to do something in this window here, in the R editor window. Now what code we're going to get we can find out from the help sheet. Here's the help sheet, and what we can do is we go down here. You can see that we've got the some notes and some code in green and blue, and if we just highlight that and copy it, we can paste that into the R editor window. We could type it in directly, of course, but this way is quicker and we're less likely to make mistakes. So let's change the stars to names that are relevant to our particular example. I'm just rejigging the windows there so we can see everything. Okay, so here we want this bit of the code reads the data into an object called P's, and does various other things that is explained in the introductory video. This bit of the code gets the frequency, produces the observed frequencies in the data. When we do a one-way chi-squared in R, it's actually a two-step process, and this is the first step where we need to find out the observed frequencies. This code here tells R to do the actual test, and in here I'm putting the name of the variable that I want it to do the chi-squared on. If you can't remember what the name of the variable is that you want, then you type, just run this bit first of the data and that will tell you, and then you can run this bit second. But we're going to do it all together. Alright, so this bit is telling us is going to get the data. Here it is, and this then it's run this second bit of code that tells us what the observed frequencies are. So that's step 1 completed. Now let's go back to our help sheet and get the code for step 2, which is actually going to conduct the test. Okay, it's been a bit awkward, hang on. Out of the way. Okay, so here then is the code for the second step, and we need to replace the stars with the numbers relevant to our particular example. Here we have the observe data. It's in 4 categories, so we put the observed data here. Now if you already have your frequencies in the you already have your observed frequencies, then what you can do is just go skip straight to the second stage. You don't need to do the first bit to get it to output the observed frequencies. This bit of the code is telling R what you want, what your expected ratio of the frequencies should be, and this is we're going to do a test of homogeneity here, so they're all the same. 4 categories, all the same, expressed as a fraction. That's a quarter each. So highlight the text, highlight it, Control R, and here this again. So just remember, these hash signs are just notes. We don't need to put those in. They just help guide us where we're going as they appear in the console and help us figure out what we did. This is the real meat of the what we've pasted here. This is the code, and the output is over here, and this gives us the statistic, the degrees of freedom, and the p-value. If as well as that you want to find a total number of items in your sample, which you should actually also report as well as that information. Then you should go over and look at the additional notes in the help sheet. And there's a bit of code here that will tell us that we can use to find out how many data points we've got. And this, what we need to put here is the name of the variable that we want to find the length of, or the sample size of. We highlight all of that, Control R, and over here that's 110. So there's the statistic, the degrees of freedom, and the p-value, and the total sample size, which is the information we need to report. If you go back to the additional notes, you'll also see here is some code for an alternative example, and I won't go through this, but what you've got is two categories here, and here, so there's the observed frequencies for the two categories, and there's the proportions of the expected frequencies. So this is actually a 3:1 ratio in this example. This would be comparing these observed frequencies to expected frequencies distributed in a 3:1 ratio. And that's it. You've done your one-way chi-squared. Well done.